Hi. In a previous video, I debunked just one aspect of the ridiculous and demonstrably impractical Solar Roadways concept. And click here if you haven't seen the video. I go through all sorts of calculations to show that it's just completely impractical. It is a ridiculous idea. And well, I thought it was all put to bed, but no, along comes another project, SolaRoad.nl in the Netherlands, and I get a whole bunch of emails and comments and all sorts of things and saying, look, they've done it. They've actually made a 70-meter long footpath, solar powered footpath in the Netherlands. No, it works. Ugh. Of course it's possible. It's not rocket science to put some solar cells under some tempered glass on a cycleway or road surface and get some energy out of it. But is it a practical idea or not? Well, as it turns out, as pretty typical in engineering, we can do some ballpark feasibility calculations. Let's go. And just a note on the previous video, it's now had almost 200,000 views and it has over 4,000 comments on it. It's gone gangbusters. Fantastic, more popular than I could ever imagine. And yet there's tons of fanboys on there trying to defend the concept of solar roadways. And well, I don't have time to debunk every single one of them. I have to leave it to a separate video. It'd be hilarious, actually, the stuff people come up with to try and defend this thing. Thankfully, all of my large engineering audience are jumping in there and just wiping the floor with them. So all those comments, anyway, it's worth a read. But out of all those commenters who tried to say that my video was wrong, my calculations were wrong, not one single person out of those 200,000 viewers came up with any evidence whatsoever to prove that my calculations were, out by any significant margin whatsoever. Nobody. That includes my own 180,000 subscribers of engineers like me, of engineering people who love to critique all my videos and point out all the mistakes. Nobody could do it. So if you can, I'm always open to being corrected on any mistakes. But hey, I think the calculations in my previous video, the feasibility calculations of what makes solar roadways and just a completely impractical idea are pretty solid, right? Nobody has come up with any data to refute it at all. So we're going to carry on from that using our base figure that we had from the previous video, and then we'll go through and we'll see if this new solar cycleway that they've got in the Netherlands is any good. Now, once again, I'll say up front, I am not anti-renewable energy, anti-solar. In fact, I'm completely for it. I had my own 3 kilowatt system installed on my roof. Click here to see the video that I did for that one, installing that. I love solar power. There's nothing more than I love than for a concept like solar roadways to work. But I'm a practical design engineer and it just smells like complete bullshit to me. And as I showed in the previous video, it's just impractical. But hey, let's go through it again. Actually, I don't mind the concept of this Netherlands-based Solar Road system at all. I think they're actually being quite professional about it and quite realistic with their goals and expectations, unlike the brochures with their solar freaking roadways, which is just pie in the sky bullshit. This one is a lot more practical. So I'm actually curious to see how the calculations actually work out. Is it going to be feasible or not? Let's find out. So what we're going to start off with is my figure that I came up with based on my own measured data and also data sheet reference values for a typical top-end solar cell. And look at the previous video if you want to see how I derived this figure. But we came up with a figure of 380 watt hours per square meter a day. That was assuming a 40% loss, and that was a best case figure. That didn't include, it includes some loss due to the glass. We didn't know the exact figure, but it was a reasonable ballpark. Didn't include the glass getting dirty and all that sort of scratched up from the road surface. all that sort of jazz. It didn't include losses from the heat effect from the solar cells as well. Their output power drops with temperature, all that sort of stuff. So, you know, it was pretty much a best case figure. So we'll start by taking a look at what they've done and what their claims and hopes are for their solar cycleway system. The whole idea of their concept is they want the solar roadways. They think that they can, you know, pave all the roads with solar panels and it'll fix all our woes. But they're starting off very practical. They've done a 70-metre prototype cycleway in the Netherlands. It costs 3 million euros. It's funded by the local council or something like that. You know, some sort of official agency is paying for this thing. So, you know, it's pretty legitimate, and the company's set up and they seem to be doing some really decent engineering and a lot of work in this. So my hat's off to them from that aspect. It's great to get prototypes and get data out of something like this. Anyway, the claim or their hope is that a 100-metre section, they've only built 70, but they claim that a 100-metre section will power typically 3 houses. Well, we can get some average data on that and go through the calculations and see where it leads us. And by the way, I'll include links down below in the video description for all of the reference data and stuff I can that I'm going to use in this thing. I'll try not to use any unreferenced data, and where it's assumed, I'll tell you that, okay? And it'll be a reasonable engineering assumption. But anyway, I found this data. It's reasonably old, but it's still not bad for average household electricity consumption in the Netherlands, which is where this thing's built. So let's get the country right. And you can see it ramping up quite significantly, but I'm going to be a bit generous and say it caps out at, or it's currently 3,200 kilowatt hours total consumption per year for one house. So they claim 3 houses. Okay, by the way, you divide that by 365, you get 8.8 kilowatt hours per day. You multiply that by 3 houses, and your average consumption for 3 houses is 26.4 kilowatt hours per day. Brilliant. And it turns out that SolarElectricityHandbook.com have a handy little calculator for real measured insolation, solar insolation data, i.e. how much energy over time hits the surface of the Earth, and by country and by city. All the data's there available. So here we go. I chose the solar insolation for Amsterdam, of course, where this thing's actually installed. So we get some real data here, okay, and for a flat panel, because these things are flat on the road surface. You get about a 30% loss in that case, okay, when it's flat like this. And from this real measured data, we get an average figure of 3 kilowatt hours per square metre per day. That is how much solar energy actually hits a 1 square metre of solar cell in the Netherlands. And that sounds like an impressive figure, doesn't it? 3 kilowatt hours per square metre, but aha, that is the solar energy hitting the thing over time. The solar cells aren't that efficient. As per the first video, one of the best solar cells on the market, currently 185 watt hours per square metre for 1,000 watt hours per square metre insolation. So they're 18.5% efficient. So we have to take 18.5% of that figure. It gives us 555 watt hours per square metre per day. But hey, we're trying to do a feasibility calculation on a real practical system here to estimate what practical results they're going to get out of this thing. So we have to add in some losses. Here is where we have to make a couple of assumptions, and I think, you know, they probably balance out quite well. And you can agree or disagree with me. You know, it's not going to make a huge difference to the final value when it all washes right out the end. So those who want to complain, oh, I've added too many losses in here, well, take them out and read and go through and do all the further calculations I'm going to do yourself. And in the scheme of things, I'm not out by an order of magnitude, okay? And that's what we're trying to get here. Ballpark calculations, order of magnitude stuff. We can probably get a lot better than order of magnitude. Anyway, losses here, I'm going to include 10% for the cables inverter, exactly what I did for my first video, 10% for the extra glass on this thing. Remember, this thing has 10mm thick glass at least on it, plus it's textured and everything else. And I think 10% loss in that glass is pretty darn generous compared to a regular solar panel which you put on your roof. They're, you know, very efficient glass on those, and they don't have to be super thick, they don't have to be textured, and you know, all that's roughened up the whole lot. So I think we're being really generous there, and quite a generous 10% loss in the surface area, because you can't cover the entire solar panel with you know, actual cell area. So, you know, roughly I'm going to round it to around about a 30% loss. There's going to be some practical system losses in there. So let's take a 30% figure ballpark, and what do we end up with? 30% from 555, we end up with 388 watt-hours per square meter per day. Look at this. Wow! What do you know? It's practically the same as the figure I got from my own measurements and calculations based on my data, which is linked in down below for my own house here in Sydney, Australia. So it's sort of confirmation that we're certainly in the right ballpark. So we're going to stick with this figure of 380 watt-hours per square meter a day. That is pretty much the best case energy we can expect out of these solar panels per square meter. So now we've got those two figures, we can figure out what we actually need, what length of solar roadway, solar cycleway we need to get their hoped and claimed for Power 3 houses. Is it the 100 meters that they claim? Well, let's take a look at it. Take these two figures in here, the 26,400 watt-hours per square meter per day consumption, divide that by the 380 watt-hours per square meter a day that we're going to get best case from these things, and it turns out, hey, we need about, in theory, best case, we need about 70 meters of this solar roadway to actually power 3 houses. And, well, they've built a 70-meter prototype, but they're saying to power 3 houses, they'll need 100 meters. Well, in the practical sense, here's a photo of their actual panel. It's not just 1 meter wide. They've only put solar panels on one half of the actual big concrete strip, so that they can do a control on the other half. Anyway, it turns out that these the solar panels are around about 1.75 meters wide. So you multiply that by the 100 meters that they think they need, and well, they're actually going to need 175 meters. So that's not surprising, because we had best case figures here. So they're actually being rather conservative, and they're implying, therefore, that they're going to have extra losses in their system. And as I said, best case, that's not surprising at all. So it turns out that their probably best case hope they can power 3 houses is actually 75% worse than our best case figure we've calculated here. So straight off the bat like that, they're not doing that great. But hey, at least they're realistic. I like it. And just for kicks, we can do a ballpark calculation for this prototype project here, the 70 meters worth. It turns out that in the Netherlands, I did some research, it's around about 0.2 euros or 20 euro cents per kilowatt hour. They don't have a feed-in tariff there apparently. Please correct me if I'm wrong, but anyway, the feed-in tariff on large scale, the government can't sustain that, society can't sustain it. So anyway, the cost, we're going to use base cost of electricity there, times our 380 watt-hours per square meter a day equals 7.6 euro cents per square meter a day. It's pretty pissant, isn't it? So multiply that figure by the 70 square meters we've got here, and I'm being generous there using my figure instead of their 75% lossy figure there, times 365 days. It can generate 1,942 euros a year. Beauty. So $3 million euro cost, a 3 million euro cost. It'll have a payback period of only 1,545 years for this project. But hey, I'm being pretty unfair. This is a prototype, so hey, that's the cost of experimentation like this. It's fine. I just wanted to do that for kicks. So yes, it's just a prototype, and there's a huge amount of R&D which went in to get to this point too. It's not just the physical construction of the thing, so don't make that mistake. So that payback calculation was just silly. Anyway, just did it for a bit of fun. They've been working on this for quite some time, and they've put a lot of R&D effort, so huge thumbs up to it. They've done quite a professional result, I think. Anyway, that aside, we just spent like 10-15 minutes mucking around doing some ballpark estimations just to show how you would go through and do these sort of calculations, because as it turns out, well, we could have just started at this point we're about to start to now, because they've already done their research and their measurements and everything, and they give us a figure of what they expect total output per square metre over a year. And they just tweeted some test results as well for 1 week's worth of operation for this thing. So let's have a look at the real data. Okay, this is what they expect from the system, 50 kilowatt hours per square metre per year, which works out to 137 watt hours per square metre per day. And up here we said, and we calculated and verified that sort of like best case, you know, in this situation is 380 watt hours. They're only expecting 137. So they're being quite realistic there, and I think that is a very realistic figure. And it's backed up by their very first test results they got, all pretty close to it. Their test results for the first week, I think it was the second week of operation, but it was like a full week, they actually got, curiously, a very round number of 100 kilowatt hours. But we will believe them, okay? But that's for the entire array. So that's for the 122 square metres, because I think it's about 1.75 metres wide by 70 metres long. I could be a little bit off there on the width. But anyway, we'll take that figure. So we divide it to get our square metre figure of 0.82 kilowatt hours for 1 week. We want a day because we're not working in weeks, so divide that by 7. Bingo, we get 117 watt hours per square metre per day. That is the test results that they're getting, and it's not too far off their expected 137 watt hours there. So brilliant, and I think it's like not an ideal time over there for generating power, and who knows what the you know, the solar insolation figures were for, you know, last week or whatever. So anyway, but it's ballpark, so they're getting pretty close to what they expect, and that's what I would have expected from the system as well. All this best case stuff was, I was being very generous, and they're clearly not getting that, and they clearly don't expect to. Now let me be very clear here, I am using now their figure, okay? It's nothing I've calculated, I'm using their expected figure, which has been fairly well verified to a reasonable margin by their actual test results. So, if we're going to generate 50 kilowatt hours per square metre per year, their own figures, at 20 euro cents per kilowatt hour, that's 10 euros a year per square metre. What the? So, welcome to the world of practical engineering. When you take an already borderline payback technology like solar panels and you stick them in the worst environment possible, i.e. flat, not correctly angled or even tracking, and you cover them with very thick lossy glass, and which can get scratched up and dirt and everything. You've got all the other issues, and then the heat can get trapped in there, and they can heat up and lose their efficiency and all sorts of stuff. Anyway, when you put them in the worst possible environment like that, this is what you get. You get out a crappy 137 watt hours per square metre, and this is the real payback you're going to get from it. 10 euros per year per square metre, and they're expecting a 15-year payback on this, once again based on their own numbers, verified by their own test results pretty much, times 15, 150 euros a year per square metre. That's all you're going to get out of this thing. Now we have the revenue over the expected payback period of 15 years. So now we can go in and ballpark estimate the cost for these things, and we can get a pretty good base minimum on the cost of this thing too, by the way, and work out whether or not it's viable. It may or may not be. Let's see how the numbers come out. Now, the first cost we have to look at is the total installed system cost. Now, you can argue that we don't really know what that is for the roads, okay, but we know we have pretty good data on what it is for a rooftop solar system. Now, in the US and Germany, here's some data. It's, around about, just under half for Germany, because Germany are producing over 50% of their energy requirements, electricity requirements from solar power. Absolutely brilliant. I love the Germans. Fantastic. Anyway, so the German market is quite saturated, so the cost is about half what it is in the US and Japan, for example. So let's be generous and take that figure. This is a total installed system cost of around about, this is a slightly old data, so let's say it's around about €2 per watt. They're always specified in per watt here. So we have to convert it to the square meters that we're working at based on the Sun Plus E18 panel we used last time. It's around about 115 watts per square meter at $2 per watt. We're looking at about a total installed system cost, that includes the panel plus installing the wiring, the whole thing hooked up, the whole shebang, okay, of €230 per square meter. And that's not a bad base level minimum cost you can't get away from. And to think that a solar roadway is going to be less than that, it can't be, right? Solar rooftops are very simple install. So the road or a cycle path is only going to be in addition to that cost. So let's look at that. Okay, so we have our first cost is €230. Oh, by the way, we've already blown our budget. Look, over 15 years, we're only generating €150 per square meter. It's going to cost us, just for the total installed system cost, if it was a rooftop at this efficiency that we're getting, this piss poor efficiency we're getting because it's laid flat and it's covered with really thick glass and it gets grime and dirty, and a very inefficient way to do it, and they heat up more, quite inefficient way to do it, then right off the bat, it's not paid back. That's just based on a well-known system install cost for rooftops. The road is only going to be more. And let's look at the cost for that, shall we? Now, as it turns out, you can actually get data for what it costs on average to construct a road. And here's some data from the World Bank. And so, it's a pretty authoritative data. They've looked at like 92 different construction projects and averaged the cost and everything else. And there's different levels of cost, whether like they're just resurfacing the road is quite cheap, whether they're building it completely from a new road from scratch, which is massively expensive, or in this case, because we have to rip up the existing roads, these things are made out of concrete, big concrete slabs, you have to rip up the existing road and put them down. That is essentially a rehab cost. So I've converted it to euros. It's around about 172,000 euros per kilometre. Average road might be, say, 8 metres wide. That's a total of 8,000 square metres. So therefore, we divide that to get our per square metre cost. 172k euros divided by 8,000. It's around about 22 euros per square metre rehab cost to install the road. That's actually not bad. So, in comparison to it's an order of magnitude less than what the system cost is for the solar panel. So it doesn't add a huge amount on there to actually put it in a road. But now we've got the glass, because these things, if I've read correctly, are wedged between two sheets of glass. The top one is at least 10 millimeters thick, and I've looked around for sort of like average industrial prices for like tempered glass, and because this isn't regular tempered plate glass, this has got the special coating on it, right? Special anti-glare coating, special anti-slip and all that sort of jazz, right? All that textured surface, that costs money. So if they're going to have that plus an extra layer under it, cost I've seen for this regular plate tempered glass, about $10 per square metre, let's say 10 euros. I'm going to double that because we might need two top and bottom. Could be a little bit out here, but I'm going to add 20 euros per square metre for the special glass they need. Remember, it is special, it's not just regular stuff, so hard to get a cost on that. But I think that's reasonable. And then you've got the special manufacturing cost, because this is a big concrete panel, right? It's, it has to be specially manufactured, the glass has to be embedded in there, they're going to install all the system wiring to it, and they've got to seal it up, and they've got to do all sorts of jazz, right? And they've got to have connectors on the side, everything else. that costs money, right? And look, I don't know, so I'm going to make up a figure based on my, rough sort of manufacturing experience. I'm going to say if it doesn't cost 20 euros per square metre for specially manufacturing these panels, I think I'll eat my hat. So let's add $20 on there, and you add these up, we're getting closer to 300 euros per square metre, 292, almost double what we're getting here. And by the way, this doesn't include like maintenance cost on these things. When you put them on their rooftop, they're almost maintenance free. When you use them as a road or a cycle service for cycling and footpaths, not so bad. Road services, all bets are off. That's just ridiculous. So haven't even factored in any maintenance costs, things like that. But even the total system install costs, we're not even in the ballpark of making this idea financially viable, even for a cycleway, let alone a road. It's not going to work. Now, here's where we get to the heart of it. And sorry about all the waffle before this. I wanted to go through. I could have just shown it just here and about what I'm going to tell you now. This is why Solar Roadways is a fundamentally and inherently stupid and impractical idea. It can't and will never pay for itself, and here's why. Okay, the rooftop solar system is 230 euros per square metre installed. A road-based system is at least 300 euros per square metre installed, plus there's maintenance, which you don't really get with the rooftop systems. And the thing is, the rooftop system is 4 times more efficient than the road-based system, based on their real measured data that we got up here. It's 4 times more efficient for half the cost. And that's the takeaway from all this. Rooftop solar systems are at least 4 times more efficient for at least half the cost, at least, with no maintenance issues. That is why you get reasonable payback period with solar. If you go through the actual calculations, you can, and based on the figures here, it's pretty easy, but I won't show it. You can pay back in like 6 years or something like that based on the figures that we've used here. But solar roadways or solar cycleways will never, ever pay for themselves. It's a fundamentally, inherently stupid and impractical idea. And this is why I wish it worked. I wish it did, but it's not. Just based on this very simple calculation here, based on their own estimates and measured data, it can't pay for itself, let alone all the extra cost to build the road. Oh, it's just... Now granted, as I've said previously, there might be some niche application where you don't necessarily care about the payback, but where it makes sense to actually put solar panels in pavement. For example, in a nice modern park or something like that for street lighting. Then that's what they claim with this project. They claim maybe we can do the street lights plus the traffic lights and things like that. Yeah, maybe, but it is always going to be more efficient and cost effective and better, and hence better for the environment, better for everyone in terms of, and for maintenance issues, everything else, if we just do solar systems as we've traditionally done them. Put them on the rooftops, put them on poles, put solar farms, feed them into the grid, whatever, because it's just a vastly more efficient and better way to do it. And if you want to argue that, well, the cost of solar panels is coming down, they're almost at free commodity prices. They're, according to one graph here, they're down to like 36 cents per watt. I mean, they're practically free, these solar panels. It's just crazy, okay? So even if you got the solar panels for free, go through the calculations, it's all the install cost, everything else, let alone the maintenance we haven't even looked at for the system. That is always going to dominate, and that stays the same regardless of what the actual solar panels cost. So anyone who claims that, oh, in the future they're going to cost less, you're missing the whole point. And if you want to argue, well, solar panels are getting more efficient all the time. What if they suddenly get to 50% efficient or something like that? Well, go through the math again. It's always going to be fundamentally better, more efficient and lower cost overall system cost and maintenance and everything else to install them on the rooftops, not in the worst possible location, flat and covered with thick glass, covered in grime and everything else with maintenance issues. It's just, that that equation is always going to remain the same regardless of what the price of solar cells do, regardless of the efficiency in solar cell. A lot of people, a lot of commenters on the previous video didn't seem to understand this, and I don't know why. It's a very simple concept. Solar roadways will never, ever be viable. And like I said, this is not even mentioning the fact of using solar panels and glass as a road surface. And there are dozens of showstoppers right there, which, you know, you can do a dozen videos on each one of those. But, you know, let's just, beside that point, hey, I think they're reasonably, they're quite okay for like a cycleway and things like that. Like for a niche application, yeah, I can see some, maybe, it's probably worth the money to actually research and develop this thing and maybe get some, some funky cycleways in some high-tech park or something like that. But if you're going to use them for practical purposes, like for, saving the world and doing it on a mass scale, it's just not going to happen. And likewise, here we go. I got so many people commenting on the previous video that, if they said that about the motor car, it would never happen, it'd never take off. And, they compare it to going to the moon, or they compare it with some other invention, the light bulb, whatever, they want to compare it to. They think that all it needs is money and, and R&D and support from people like me, and it will be, and more R&D, more money, more time, and it'll be a viable technology, more research, all that, and it'll make it all magically viable in the end. No, it won't. There are fundamental, basic, practical costs in here which don't make it viable. Not every idea that comes along is inherently practical and viable. That's just the way it is. Sorry for all you people who want to believe in solar roadways, but believing in it is not enough. Just do the simple calculations, use some common sense, look at the figures, and you'll just realize it's just never ever going to be viable. Sorry, I wanted it to be, I wish it was, but it ain't. So that's it, I'm done. Look, solar roadways, but it won't stop the commenters. You watch, just read the comments down below how I've got it all wrong and I'm not supporting them and blah 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 bloody blah.